Hello coders, I welcome you all. In this video, we are going to build another project using machine learning, restaurant review classification using machine learning. We call it restaurant review classification or restaurant review sentiment analysis. As you know, in online trends, everyone is focusing on reviews. Before purchasing something, we check reviews. Not only for purchasing, but before going to a restaurant, we also check reviews. In the past, we used to get reviews from our friends and family. Reviews not only matter for customers, but are also crucial for the owner to expand the business and improve product quality. Sentiment analysis helps in this regard. It determines whether the sentiment from the review is positive or negative, helping the owner run a better business. So in this video tutorial, we are going to build a restaurant review classification using natural language processing. We will use a real-world dataset available on Kaggle that you can see over here, restaurant customer reviews. You can download this dataset from here, means from Kaggle or from my GitHub account. Link is provided in the video description. As you can see here, about data set. Context. Most of the restaurants ask reviews to the customers, and based on the reviews, the restaurant can improve the customer satisfaction. So the reviews plays a vital role for the successful growth of the restaurant. And content. The data set consists of 1000 rows and 2 columns. First column is review column. Review column consists of customer reviews, and another column is liked column. This like column consists of 0 and 1. If the review is positive, 1. And if negative, then 0. You can see here our dataset with 2 columns, review and liked. As I said, review columns consist of customer reviews that you can see over here. And this liked column consists of 0 and 1. If the review is positive, then 1. If review is negative, then 0. That you can see over here. So you can download this dataset from here. Just click on this download button. I have already downloaded this dataset. So this way you can download the dataset. Now let's move on. This project is essential for future NLP projects. We will apply step-by-step processing, including loading the dataset, pre-processing the text cleaning such as stop words removal and stemming. Additionally, we will create word cloud to identify the main words used in negative and positive reviews. Then we will use various machine learning models. Finally, we will select our best model for production, and then we will deploy our best model. So let's get started. Before we move towards the coding part, you can see how our final product looks like, that you can see over here. I have created a desktop app using tkinter. Let's provide a review as input. Let's copy this and let's paste it over here. Let's press this button, classify. As you can see here, predicted sentiment positive. Let's take second review. Now let's press this classify button. As you can see here, predicted sentiment negative. So when we press the classify button, this input is given to our pre-trained model. It executes a series of steps on this input text, and then it shows the output on the screen. Predicted sentiment negative or positive as per the given input. So now let's write code for this project. Let's jump to Jupyter Notebook. Now first, let's import the libraries we need. We will import others when they are needed. So let's first import pandas as pd. Let's import numpy as np. Also matplotlib.pyplot as plt. Also warnings. Let's execute this cell. As you can see here, our required libraries are successfully imported. Now let's write warnings.filter warnings, and here ignore. So this code to ignore warning messages in our program. Let's execute this cell. So now let's import our dataset. So pd and read_csv, and our dataset with name restaurant_reviews.tsv. As you can see here, our dataset is in the TSV format, tab separated values format. So therefore, we need to use this sep parameter of read_csv method with /t for tab argument, which specifies that the data is in tab separated values format. And let's assign it to one variable data is equal to this statement. Let's execute this cell. As you can see here, now our dataset is successfully loaded as pandas data frame. So now let's print the first 5 rows of the data frame using head method of pandas data frame. To quick inspect a few initial rows. So you can see our dataset contains two columns, review and liked. So review is an independent variable and liked our target variable. So liked column contains two values, 0 and 1. So in this context, 1 represents a positive review while 0 represents a negative review. And you can see our review column contains text as a review. So we have to process text. So now let's first check shape of our data set. As you can see here, our data set contains 1000 rows, means 1000 samples. Also we can say 1000 reviews and two columns, review and liked. Now let's check for missing values in our data set. So for that we have to write data which is pointing to our data frame, and we have to use isNull method of pandas data frame. Let me execute this cell. As you can see here, output is pandas data frame with boolean values. Let's perform sum of true values. As you can see, by looking at the output, we can see that there is no missing values in our data set. Now let's check whether our data set is balanced or imbalanced. So for that we have to use our target column like and value counts method of pandas data frame. Let me execute this cell. So this is the way to obtain count of each unique value in the liked column. As you can see, our data set contains same number of samples for positive and negative reviews. So we can say that our data set is highly balanced. Now let's move on. Let me display first 5 rows from our data set. Now let's count number of characters for each review entry. So for that, let me write data and we have to use our review column, and let's use apply method and length function. So this apply method will apply this length function on each and every reviews to count number of characters for each reviews. And let's create new column with name character underscore count. You can give any other name as well. Let's execute this cell. So this line of code adds a new column named character underscore count to our data frame containing the character count of each review entry. Let me show this. Let's check first 5 rows. As you can see here, we have successfully added new column which contains character count of each review entry that you can see over here. Character count for this first review, character count for the second review. Likewise, same way we can also count number of words. So again, for that, let's use review column. Again, we have to use this apply method, and this time we have to use lambda function x and in length string x, and we have to use split method to split our reviews by space. Again, let's create new column with name word underscore count is equal to this statement. So this code creates a new column named word count in the data frame which represents the word count for each review entry using a lambda function to split the text into words and calculate their length. Let's execute this cell. Let's check. As you can see here, we have successfully added two columns, character count and word count. Same way, we can also count number of sentences available in each review. Let me show this. So for that, we have to use NLTK library. So let's import NLTK. Let's execute this cell. Also, let's write NLTK dot download punkt. Let's execute this cell. As you can see, output is false. So let's connect my computer with internet. Please wait for a while. Now just I have connected my computer with internet. Let's execute this cell once again. As you can see here, output is true. So this code obtains the necessary files and data for NLTK to perform sentence tokenization. That's why here we are downloading it. Let's use our review column, apply method and lambda function. Here we have to use NLTK dot send underscore tokenize method on each reviews, and we are interested in count. So again, let's use length method. Let's execute this cell. As you can see here, sentence count, but let's create new column with name send underscore count is equal to this statement. Let's execute this cell. Let's check. As you can see, we have successfully created 3 columns, character count, word count and sentence count. Now let's calculate average of this character count for positive reviews and for negative reviews. So for that we have to write data, and here we have to use our target column liked is equal to 1. For positive reviews, let's pass it to our data frame. As you can see here, positive reviews and character count dot mean. Let's execute this cell. As you can see here, average character count for positive reviews. Let's copy this, let's paste it over here, and same for negative reviews. So here like is equal to 0. Let's execute this cell. As you can see here, average character count 60.75. Here average character count for positive reviews 50.88. Same way you can calculate average word count and average sentence count. So from the output we can observe that negative reviews have a higher length compared to positive reviews. This holds true for words and sentences as well. Now let's move on. Let's clean the text now. So for that, let's first import module RE for regular expression. Let's execute this cell. So now first we are going to remove all non-alphabetic characters and replace them with spaces. So now let's check our first review. Now let's replace all non-alphabetic characters that you can see over here with spaces. So let's write re dot sub method of re, and here let's use A to Z lowercase, A to Z uppercase. So we want to keep these characters only alphabetic characters, and we want to replace all non-alphabetic characters with space. From review 0 at index 0 means first review, and let's assign it to one variable review is equal to this statement. Let me execute this cell. Let's check. As you can see over here, so we have successfully replaced all non-alphabetic characters with spaces that you can see over here. Now let's convert this review into lower case with this lower function. Again, let's assign back. Let's execute this cell. Let's check. As you can see over here, reviews in lower case. Now let's split this review and let's again assign it to review. Let's execute this cell. Let's check. As you can see over here, so just we have taken this first review and we have replaced all non-alphabetic characters with spaces. Then we have converted it into lowercase. Then we have splitted this particular review, first review that you can see over here. Now let's move on. Let's remove stop words from this particular review, from first review. So for that, we are going to use NLTK library. So we have to import from nltk.corpus. Let's import stop words. Let's execute this cell. So we have successfully imported stop words from nltk.corpus. Now let's write stop words dot words, and we are interested in English stop words, and let's assign to one variable all underscore stop words is equal to this statement. Let's execute this cell. Let's check. As you can see over here, these are the stop words listed in NLTK that you can see over here. Now let's remove stop words from this particular review, first review. So I'm going to use list comprehension. So for word in review, if word not in this set, all underscore stop words, then let's print that particular word, and again I am assigning it to review variable. Let's execute this cell. Let's check. As you can see over here, so as you know, stop words are the most frequently used words in a language, such as articles, prepositions, conjunction, etc. These words don't contribute much meaningful information to the text. Examples of English stop words are the, a, and, so, what, etc. Right? So stop words are removed to eliminate low-level information from text, allowing more focus on important content. In other words, we can say that the removal of such words does not show any negative impact on the model we train for our task. Removal of stop words reduces dataset size as well, and thus reduces the training time due to the fewer number of tokens involved in the training. Please remember, stop words are not always removed. The decision to remove them depends on the task and the goal. For example, currently we are performing sentiment analysis. So in sentiment analysis, stop words may not be removed. Removing them can alter the meaning of a sentence. Let me show you this. Let's take next review. As you can see here, crust is not good. This is a negative review. So we have removed all non-alphabetic characters. Let's convert into lower case. Let's perform splitting. Let's try to remove stoppers. As you can see over here, output is crust good. So here we can clearly see that the review was negative, that you can see over here. But however, after removal of stoppers, the review becomes positive. So the removal of stoppers can be problematic here. So for better sentiment analysis, we have to remove such stoppers from the default list. Let me show you this. So let me write all underscore stoppers dot remove. Let's remove this node from the default list of stoppers of NLTK. Let's execute this cell, this as well. Let's execute this cell, this, and this as well. Finally, you can see crust not good. So we are going to keep such stoppers that help us in sentiment analysis. Now let's move on to our next step, stemming. What is stemming? Stemming is a text normalization technique used in natural language processing and information retrieval to reduce words to their base or root form. The goal of stemming is to map different variations of a word to a common root, which helps in grouping similar words together and simplifying the analysis of text. In stemming, suffixes or prefixes of words are removed to obtain the root form, also known as the stem. We are going to use most commonly used stemming algorithm, Porter stemmer, from NLTK. So let's import from NLTK.stem.porter. Let's import Porter stemmer. Let's execute this cell. Let's create instance of this Porter stemmer as PS. Now let's use list comprehension. So for word in review, to perform stemming, we have to use stem method of Porter stemmer on word. Let's assign it to review. Let's execute this cell. Let's check. Also, we can join this review using this join function, and let's assign to review. Let's execute this cell and this cell as well. As you can see over here. Here we have performed data cleaning and pre-processing on just one review. The same we have to apply on this 1000 reviews. To do that, let's group all data cleaning and pre-processing tasks into one box. As you can see here, I have created one set with custom stoppers that we are going to remove from the default list of stoppers, because as you know, we are going to perform sentiment analysis, right? So once again, let me create instance of Porter stemmer that we have already imported. Also stoppers dot words, and we are interested in English stoppers minus this custom stoppers that we want to remove from default set of stoppers, and let's assign it to one variable stop underscore words is equal to this statement. Let's execute this cell. Now for I in range length of our data frame, and now let me copy this statement and let's paste it over here. In place of 1, here we have to pass I for all the reviews. Same for this lowercase as well. Let's convert all the reviews into lowercase. And then we have to split all the reviews. And now let's perform stop word removal. So for word in review, if word not in stoppers, this one, then let's perform stemming on word. Again, let's assign it to review. Again, let's join the words. Let's assign back to review. And let's create one empty list with name corpus, and corpus dot append this review. So after data cleaning and pre-processing, we are appending reviews into this particular list. Let's execute this cell. Now all done. So now let's create new column with name processed underscore text with corpus, this one. Let's execute this cell. Let's check. As you can see over here, our processed text. Now let's move on. Now let's display word cloud. So word cloud is the pictorial representation of the most frequent keywords in the dataset. Let me show you this. So for that, we have to import from word cloud, import word cloud. Let's execute this cell. Now word cloud, and here we have to set width and height. Also we can set minimum font size. Let's set to 8, and let's set background color to white. You can select black as well. Let's assign it to one variable WC is equal to this statement. Let's execute this cell. Now let's display word cloud for positive reviews. Data, you can see positive reviews. We want to display using this processed text, and let's convert it to string, and we have to concat it through space, and that we have to pass in generate method of word cloud. Let's execute this cell and let's assign it to variable POS for positive. Let's execute this cell once again. As you know, we have already imported matplotlib.pyplot as PLT, this one. So let's use plt.imShow method. And here we have to pass this particular variable POS. Let's execute this cell. As you can see over here, our word cloud. In a word cloud, the font size of words is directly proportional to the frequency of the word. As you can see here, higher the font, higher the frequency. Like great, best, good, that you can see here, occur more frequently in the positive review. So this way we can display word cloud. Let's display word cloud for negative reviews as well. So just in place of 1, we have to put 0. And let's assign it to variable negative. Again, plt.imShow, and here we have to pass this variable negative. Let's execute this cell. As you can see over here, wait, place, never, disappoint, that you can see over here. Such words occur frequently in negative reviews, that you can see over here. So this way we can display word cloud, which is pictorial representation of the most frequent words in the data set, that you can see over here. So now let's move on. Let me display top 5 rows of our data set. As you know, our target variable, this one, liked, contains 2 values, 0 or 1, making this a binary classification problem. So we are going to use different classification algorithms to classify reviews. However, we can't train machine learning models on text directly. We have to convert this text into numerical values. So we are going to use bag of words technique, which is directly available in scikit-learn as count vectorizer. Just remember, we are going to convert these reviews into vectors using count vectorizer. In simple term, we can say that count vectorizer converts text into a numerical format. So in the next step, we can use different machine learning algorithms to classify these reviews. So before we start coding, let's discuss count vectorizer first. As I said, a count vectorizer is a text processing tool used to convert a collection of text documents into a numerical format. It's one of the most basic and simple methods to convert a list of words to vectors. Using a count vectorizer, we can represent these reviews as a metric. So each row in table represent a specific reviews. In this example, we have taken first 3 reviews. But as you know, our dataset contains 1000 reviews. Now you can see columns. Each column corresponds to a unique word found in entire collection of reviews after stop words removal and stemming, right? So these words are extracted from the entire set of reviews and are listed as column headers here. Now values. So values in the table represent frequency of each word in each review. So as you can see in this table, the word wow appears once in this particular document. Love appears once in this particular document, means in this particular review. Ace appears once in this particular review, and the rest of the words are absent. Similarly, in doc2 means review 2. Trust and good appear once each, and all other words are absent here. So this way, using count vectorizer, we can represent different reviews as a metric that you can see over here. Now let's jump to Jupyter Notebook. We will discuss there in more detail. Now let's first import count vectorizer from sklearn.feature_extraction.text. Let's import count vectorizer. Let's execute this cell. As you can see here, we have successfully imported count vectorizer. Now let's create instance of count vectorizer. And here I am taking max_features is equal to 1500. And let's assign it to one variable CV is equal to this statement. Let's execute this cell. So here we have taken max_features is equal to 1500. So the count vectorizer will only include the 1500 most frequent words in our corpus. So you are wondering why 1500? You can choose 1500, 2000, 2500, 3000, etc. Any other number based on the performance of your system. but lower is better because a smaller matrix is easy to process, right? Now let's write CV underscore fit underscore transform on our corpus. Let's execute this cell. As you can see here, fit underscore transform of sklearn returns a sparse matrix and it is in compressed form. So this is for efficiency reasons, especially when dealing with the large data sets where most entries are 0. So let's convert this into dense array using to underscore array and let's assign it to one variable x. Let's execute this cell. Let's check x. As you can see here, we have successfully converted our text to vectors. Now we can apply different machine learning algorithms on this vectors. Let's check shape of x. Can you guess what will be the shape of the x? Please remember, total we are having 1000 reviews and we have taken 1500 most frequent occurring words in our corpus. So obviously the shape will be 1000 cross 1500 like this. So here we have selected 1500 most frequent occurring words in our corpus. And here total we are having 1000 documents, means 1000 reviews. That's why X shape is 1000 cross 1500. So as you can see, here we have assigned this to X that you can consider as our features, means independent variables. Now let's assign our dependent variable to Y, light. Let's execute this cell. Let's check. As you can see over here. So now we have our independent variables, means features, and our target variable. So now let's apply different classification algorithms on this particular data. So now to train and evaluate the performance of machine learning models, let's use train test split. From sklearn dot model underscore selection, let's import train underscore test underscore split. Now train underscore test underscore split, here let's pass our independent variables and our dependent variable. Let's set test size to 20%. We are keeping aside 20% data for testing purpose. And let's set random underscore state to 42. And here x train, x test, y train, and y test. Here total 4 parts, but 2 set, one for training and one for testing. So we are going to train our machine learning models on X train and Y train. We will perform prediction using X test and we will compare our predicted results with Y test. Let's execute this cell. Now let's use our first model. From sklearn dot new base, let's import Gaussian new base. Let's create instance of this Gaussian new base. Now let's train our model on X train and Y train on our training set. And now let's perform prediction on our unseen samples available inside X underscore test. And let's assign predicted values inside Y underscore pred. Let's execute this cell. Now let's find accuracy score. So for that we have to import from sklearn dot matrix. Let's import accuracy score. Let's execute this cell. Now let's find accuracy score for Gaussian new base. So here we have to pass actual values and predicted values by our model. Let's execute this cell. As you can see here, Gaussian new base is 68% accurate on this particular data set. Now let's use our another model, logistic regression. From sklearn dot linear underscore model, let's import logistic regression. Let's create instance of logistic regression with LR. Let's train our logistic regression on our training set on X train and Y train. Now let's perform prediction using our unseen samples available inside X underscore test. And let's assign it to one variable. And we have already imported accuracy score. So let's find accuracy score for logistic regression. So here we have to pass actual values and predicted values by our model. Let's execute this cell. As you can see here, logistic regression is around 79% accurate on this particular data set. So now let's use our another model, random forest classifier. So for that we have to import from sklearn.ensemble. Let's import random forest classifier. Let's create instance of a random forest classifier as RF. Let's train our random forest classifier on training set on X train and Y train. Let's perform prediction on our unseen samples available inside x_test. Let's assign predicted values to y_thread. And let's find accuracy score of random forest. Again, here we have to pass actual values and predicted values available inside y_thread. Let's execute this cell. As you can see here, random forest is 80% accurate on this particular data set. So as per the result, we can say that random forest is the best model for this particular data set with accuracy of 80%. So we are going to use random forest in our production. So now let's save our best model, random forest classifier. So again and again, training is not required and we can perform prediction using our saved model. So for that, let's use joblib library. Let's write joblib.dump. Here we have to pass model instance. And here you can provide any name, restaurant_review_model. You can use any other name as well. Let's execute this cell. As you can see here, we have successfully saved our best model, random forest classifier. So now we can perform prediction using this saved model. So if we want to perform prediction using this saved model, we have to perform pre-processing that we did earlier, like this: stoppers removal, stemming, and this. So for that, here I have created GUI that will pre-process our review to perform prediction on unseen samples that I have created exactly same way as we have created for our previous projects. Also, you can take this code from my GitHub. Link is provided in the video description. Let's execute this cell. As you can see over here, this is our GUI. So we can perform prediction using this GUI. Let me show this. Let's take this first review. Let's press this button, classify. As you can see here, predicted sentiment, positive. Let's take another review. Let's remove this and let's paste it over here. Let's press this button, classify. As you can see here, predicted sentiment, negative. So this way we can perform prediction using this GUI. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.